In this video, I'm going to show how to quantify uncertainty, and based on this, to decide whether the addition of a mediator in a model is relevant, specifically whether it reduces uncertainty. Now, for that, I will be using two papers. The first one was published in International Journal of Consumer Studies, and it introduced a procedure to compute uncertainty generated by model selection. And using this procedure, I'm going to apply the method proposed in the paper published in Journal of Marketing Analytics to quantify uncertainty, and based on this to decide whether a mediator is relevant or helps with reducing uncertainty in a model. Now, let's suppose we have a baseline model which assumes that the environmental responsibility of a brand has a direct impact on customer brand identification, as well as on customer loyalty. Also, there is an impact of customer brand identification on customer loyalty, and obviously an indirect impact via this identification, an indirect effect of environmental responsibility on customer loyalty. So the base model is already drawn in Smart PLS, and you also can see it in the left part of the screen, marked with yellow. So just to start, let's go for this baseline model and compute the confidence intervals of each relationship in the model. For that, I will be using bootstrapping with 10,000 bootstrap samples. I'm going to run it. And we're going to just save the results. So first we have the direct effects, the confidence intervals is what we are interested in. So for the direct effect of identification on customer loyalty, we have the lower bound 0.215 and the upper bound 0.341. For the direct effect of environmental responsibility on customer brand identification, we have the lower bound 0.264 and the upper bound 0.375. Further on, for the effect of environmental responsibility on loyalty, the direct one, we have the lower bound 0.163 and upper bound 0.287. And then we also have an indirect effect for which the confidence interval says that the lower bound is 0.064 and the upper bound 0.117. So actually, these are the results for the baseline model, which includes three constructs: environmental responsibility, customer brand identification, and customer loyalty. Three direct relationships and one mediated relationship, an indirect effect. Now the question is, would adding a mediator to this model help us reduce the uncertainty of these assessments? Because, for instance, we can look at the widths of the confidence intervals that have been obtained, and we can see that they are pretty consistent, especially for the direct effects. So what we can do is think about an additional construct which should play a mediating role. Now, this additional construct in this model could be satisfaction, customer satisfaction. There is one relationship which is self-evident, the impact of satisfaction on loyalty, the direct effect. However, the way satisfaction might play a mediating role is not certain. So we have three competing models, as you can see on the left part of the screen. One competing model which assumes that customer satisfaction is a mediator between environmental responsibility and loyalty and has no direct relationship with customer brand identification. Another competing model, Model 2, might assume that there is no direct impact between environmental responsibility and customer satisfaction, but rather a direct impact between identification and satisfaction. Third, we can also have this competing model, Model 3, in which satisfaction has direct relationships with all the other three constructs in the model. So adding a mediator to the baseline model would actually involve three competing models. And because we have to select one of these three competing models, we will have an uncertainty which is generated by model selection. And this is computed using the procedure described in the paper published in International Journal of Consumer Studies. Now, how do we do that? Well, first, we need to compute the Kaike weights. That means using an algorithm which is described in the paper that I referenced before. I've already prepared a sheet which computes everything automatically based on the procedure described in the paper. It's not very complicated. And what we need to do is to run the PLS SEM algorithm for each competing model and save the information criteria. Now, let's go for model 1, run PLS, go to model selection criteria, and then take out from here the Bayesian information criterion for our target variable. Our target variable is customer loyalty. So we have minus 748.617. Now we do the same thing for the competing model number 2. We run the PLS algorithm, we go to model selection criteria, and we take out the information criterion value, which is minus 747.539. And finally, we go to model number 3. We run the PLS SEM algorithm. We go to model selection criteria, and we get the Bayesian information criterion, which is 747.895 with a minus before. Now, based on this Bayesian information criteria values, we are now able to compute Kaike weights, and based on this, we would now be able to determine the number of bootstrap samples to be considered for each model in order to calculate confidence intervals, so that the total bootstrap samples equals 10,000. The same bootstrap samples, the same number of bootstrap samples that we used for the baseline models when we ran bootstrapping. And now what we're going to do is just run bootstrapping for each competing model using the number of bootstrap samples determined via the procedure. So this is model number 1. We run bootstrapping, but we're going to use 4,385 bootstrap samples. And most importantly, we need to check save results per sample, because we will need the results for all the bootstrap samples. Let's go for start calculations. And now we are interested in the bootstrap samples, and we find them in the section titled Samples. We have all the confidence, all the path coefficients for all the bootstrap samples, more specifically 4,385 samples. We copy them and save them in an Excel sheet. Now we're going to do the same thing, specifically save the coefficients for the indirect effects. So we're going to copy the indirect effects as well and save them. Now, what is also important is to focus on the three relationships that we have included in the baseline model. So we have three direct relationships between the three constructs included in the baseline model, and one specific indirect effect, environmental responsibility on loyalty via customer brand identification. So we have four coefficients that we are interested in, because this is what we are assessing, and this is what we're trying to reduce the uncertainty for. So now we go back to the sheet and we just remove all other relationships that are of no interest for now. So we're interested in the direct relationships included in the baseline model. So those do not include satisfaction. So this, as well as this, are not relevant. This one neither, because these all include a variable, a construct, which was not part of the baseline model. Now, we say this, and now we go for model number 2, because we need to run again bootstrapping, this time for model number 2, and with a different number of bootstrap samples, specifically 2,558, as resulted from the procedure based on KK weights. So again, we need to check save results per sample, because we need to save the coefficients for each bootstrap sample. We run the bootstrapping, and then we just make sure we save all the coefficients. So we go to the section samples. First, we take the path coefficients, and then we go for the specific indirect effects. We copy this as well and remove everything that is not relevant for this analysis. So we are focusing again on the relationships included in the baseline model, because we need to see whether their assessment can be more certain with a mediator added. So we go back, and then everything that includes satisfaction, which is the additional mediator, will actually go out of this sheet. All right. So we only kept the 4 relationships included in the baseline model, 3 direct relationships and 1 indirect effect. Finally, we go to model number 3 and repeat the bootstrapping analysis, this time, of course, with a different number of subsamples. So this is 3,057 as resulted based on the procedure with KK weights. Again, make sure you have checked the save results per sample, and we start the calculation. All right, we go to samples. We save coefficients for each bootstrap sample for the direct effects, and then we go for the specific indirect effects. We copy this as well, place them in the sheet, and just as we did before, we are removing all the relationships which include the additional mediator, so that we can focus only on the relationships that are included in the baseline model. So this includes satisfaction, this also includes satisfaction, this as well, and this as well. So we delete this, and now we are focusing on the 4 main relationships from the baseline model. What we do next is combine the results of the 3 bootstrappings. So we have a new sheet here called Combine, where I'm going to just copy paste all the results from all the three bootstrapping procedures. So I'm going to bootstrapping model 1. I'm going to take all the results from here. I'm going to copy them. I'm going to the combined sheet, and I'm just pasting them. And I'm going to add the other results from bootstrapping model 2. I'm going to just copy all the results from here, copy, and then paste in the combined sheet. And finally, I'm going to add the results from the third bootstrapping procedure. Again, copy all the bootstrap samples results, go to the combined sheet, and paste them here. And then, if I go to the end of this sheet, I should have 10,000 samples, because this is what we started from. A total of 10,000 samples, bootstrap samples, which were split among the three competing models based on Akeiki weights. Put together, of course, we have 10,000 sets of coefficients for direct relationships and for the specific indirect effect. And now we need to compute the uncertainty intervals, which is just like a confidence interval, a computation based on percentiles. So I'm going to just compute percentile. I'm going to select all the values above from B2 to B10,001, and I'm going to specify 0.025 because I need a 95% confidence interval, which is this time an uncertainty interval. And this is the lower bound. And for the upper bound, we're going to use pretty much the same formula, except that we're going to change the tail. We're going to have 975 here. So this is the uncertainty interval for one of the direct relationships. And we need to compute these uncertainty intervals for all the relationships. So now we could just take this uncertainty intervals and place them here, where we also have the confidence intervals computed for the baseline model. So for each confidence interval and for each uncertainty interval, we have widths, which are in a way a reflection of the uncertainty of our assessment. So what we can see now is that, for instance, the direct relationships, the direct effect of customer brand identification on loyalty is measured with less uncertainty using an additional mediator. The width of the uncertainty interval is 0.103, lower than the width of the confidence interval of this relationship in the baseline model, which is 0.126. The same applies for the direct relationship between environmental responsibility and customer brand identification. In the baseline model, the width of the confidence interval is 0.111, and this decreases when we add a mediator, the uncertainty interval being less wide, okay, narrower. The same applies to all the other relationships in the baseline model. Direct effect of environmental responsibility on loyalty in the baseline model had a confidence interval width of 0.124. If we add the mediator, even with the uncertainty generated by the model selection, it will still be less, 0.111. And eventually, last but not least, for the specific indirect effect, again, the width of the interval, the 95% confidence interval, which for the added mediator is actually an uncertainty interval based on model selection, again, the width becomes smaller. So what's the conclusion? The conclusion is that by adding customer satisfaction as an additional mediator to the baseline model, we were able to measure the direct effects between environmental responsibility, customer brand identification, and loyalty more accurately, with less uncertainty. So that's pretty much it. I hope you can apply this procedure in your own research. The data set that was used for this illustration is the same data set that was used for the illustration in the paper published in International Journal of Consumer Studies. The data is publicly available on the Open Science Foundation site. So you could just read the paper, and in the paper you will have a link to the data set. You can download it yourself. You can recompute everything I did and maybe understand better the procedure.